Okay, this video is going to talk about one of the first topics we need to discuss in physics: distance and displacement, speed and velocity, which is just motion in general. To start talking about motion, there are a few terms that we need to define first that may sound familiar, but we use them in a very specific way in physics. So first of all, position. Something's position is quite obviously where it is, where something is, but it is in relation to a reference point, and that's really important to understand. So if you were in class, when we did the activity with the car, we had positions 0, 2, 4, 6, 8, and 10. We named those positions, those numbers, because position 2, for instance, was 2 meters from the origin, from that starting line. Position 4 was 4 meters from the starting line, et cetera, et cetera. In other words, it might be kind of obvious, but it's useful to point out that to name something's position, I have to have some sort of reference point. This thing is, I live 2 miles from the school, something like that. There's got to be some sort of reference point to name a position. The next two terms are really important, and they seem similar at first, but there's some really important differences between them. Distance, quite obviously, how far an object has traveled. That seems obvious. But the thing that is actually not in your particular notes, and you need to write this if it's not, regardless of direction. So the way I always say this is that the distance is simply the total feet that your path have taken if you're going on a hike, or it's the total miles that you put on your car when you drive from your house to school. It doesn't matter that you change directions in the process, because we don't report direction with distance. When I say, how far is it to Walmart, you say 3 miles. You don't tell me the direction unless I ask you for the directions. So distance is we just simply report a number. We don't care about the direction. Whereas displacement is slightly different. Displacement is officially defined as the change in position of an object, but there's a better way to state that. First thing you need to know is we do include the direction with displacement. Really, really important for you to know that. So let me get my pen out here. Let's do a red one. Including direction, you need to make sure that that's in your notes. I'm not sure if it's written or not. Probably depends on what year you're watching this video, but with distance, direction doesn't matter. Displacement does, because it's the ultimate change in position of an object, and I'll explain that in a few ways in just a minute. This one is the most important definition of displacement. This is the way I like to talk about displacement. It is the straight line distance and the direction from the beginning to the end of a trip. And I don't think that's in the notes for this year, but I'm planning on changing it, so it might be there when you're watching this. The straight line distance from the beginning to the end of a trip. And that's really important to know because it has several implications. So as a for instance, let's get this right here. Imagine that in that car activity, you might have remembered the car didn't actually go in a straight line. So if this was the starting line of the car actually did something like this. And I had to kick it every once in a while to make it go straight. But if I had stretched a string from the beginning to the end, the length of that string would be 10 meters. And there was, here was position 2, 4, 6, 8, and 10. The question is, that 10 meters, is that the distance or the displacement? Well, the answer is that's the displacement, because that's the straight line distance from the beginning to the end of the trip. That's the change in the car's position. It is at this point displaced 10 meters to the right of where it started. The distance the car traveled is actually farther than that, as you can probably imagine, because of the path that the car took. If this particular line was a string and we stretched it out, it would actually be longer than 10 meters, and I don't know exactly how long that would be. So this is the path the car actually took, but the straight line distance from beginning to end is still 10 meters. And then I ask, well, what if the car did something like this? Now what is the car's displacement? Well, the answer is it's still the same. Doesn't matter what the car did, because the straight line distance from the beginning to the end of a trip is still 10 meters. The car did a lot of things in between, so the displacement is the same, but the distance now is drastically different. It's probably something like 30 or maybe 40 meters because of what the car did. It traveled a much farther distance, but it ended up displaced the exact same amount as it did previously. All right, so In your notes, the next thing we need to talk about is how we indicate direction. So in this class, it's really important to understand that anything going to the right or moving up is a positive direction, left and down is usually negative. We will also see these terms, that some problems we read will use up, down, left, right, north, south, east, west. We'll use those terms. If a problem uses those directions, we'll give those directions for the answer. But you will most frequently see positive and negative in terms of direction. So it's important to understand that anything going to the right is positive, up is positive, left is negative, and down is also negative. Which is different from, I know, what you have previously learned. And so the question I usually ask at this point is, can I go negative 30 miles an hour? And most people will say, of course you can't. You can't go negative 30 miles an hour because you can't go slower than 0. And in that answer is an implication, because you've been taught prior to this that a negative number is less than a positive number, or negative 5 is less than 0. That's no longer the case in this class. Negative numbers are not less than positive numbers. Negative, this is really, really important, negative and positive only implies direction. This is all about direction. Negative and positive doesn't tell you amounts, it doesn't tell you whether it's more or less. So the answer to the question, can I go negative 30 miles an hour, is yes. And all it means is that I'm going 30 miles an hour in a negative direction, either to the left or down, or sometimes if I'm on a car, I might say backwards. Sometimes we say forward is positive, backwards is negative. So negative and positive only indicate direction. All right, so now that we have that, we have a couple of examples. I have a lizard here. Lizard started at 25 centimeters, goes to 85 centimeters. The question is, what distance does the lizard travel? Well, the distance is just the total path that the lizard took. From 25 to 85 is 60 centimeters. So we would say the distance is 60. But if I ask you what is the lizard's displacement, a lot of people have trouble answering this question because they don't know how to quite answer it. Once you know how to answer it, it's really easy. The displacement is simply, going back to what we learned before, the straight line distance, the straight line distance and the direction from the beginning to the end of a trip. So the straight line distance from the beginning to the end is still 60, but now we're just going to add the direction. The direction is to the right. So we would say 60 centimeters to the right, or positive 60. Very simple. And once we get that under control, it becomes really, really simple. So we look at all these examples. This ball went from 10 to 80. The distance is 70 centimeters. The displacement is 70 centimeters to the right. This one goes from negative 10 to 6. That's a distance of 16 centimeters. So it goes 16 to the right for the displacement. 16 centimeters is just the distance. Notice that in these other two examples, though, we're moving to the left. That doesn't change how we report the distance. We start at 15, we go to 0, the distance is 15 centimeters. It's the same distance as if the ball had gone the other way. But when we report the displacement, we'll report the direction. So 15 centimeters is the distance, 15 to the left is the displacement, 10 centimeters for a distance, 10 centimeters to the left is the displacement. So you get the point. The main difference between distance and displacement is that with displacement we also report a direction. And so now the question becomes, is distance and displacement always going to be the same number? I want you to think about that for just a minute, maybe pause the video if you want to. Is distance and displacement always going to be the same number? Because, after all, it certainly was here. All we did in these examples and in the example of the lizard is we simply added a direction. 70, 70 to the right, 16, 16 to the right. Is that always going to be the case? Is that always going to be the case? And so I always ask this question about running around a track. So most of us have at least seen a track. Many of us have run a lap around the track. Maybe you run track. If you start at the starting line and you run one lap around the track, one lap, hopefully you know, is a distance of 400 meters. You have gone all the way around, and when you get to this point, you have run a distance of 400 meters. So that is your distance. Okay? But the question is, in this example, move this out just a little bit. In this example, what is your displacement? Many people have a hard time thinking about, well, what's the displacement? And this is where what I'm trying to do is get you to understand the difference between distance and displacement. So if we go one lap around the track, think about that. Maybe even pause the video. What is the displacement if you run one lap around the track? Well, let's think about the definition of displacement. The displacement, once again, is the straight line distance from the beginning to the end of a trip. Well, where's the beginning of the trip? Starting line. Where's the end of the trip? Starting line if you run one lap. And the distance between those two, the displacement would actually be zero. Zero. You are not displaced because your change in position from the beginning to the end of the trip is nothing. You are right back to where you started. Imagine that you have if you have like a retractable leash for a dog, you know how there's always like a straight line between you and the dog that is represented by that leash. So if you were running and you had that leash attached to you and it was also attached to the starting line, you might go around this point, and if I pause the video right here, at this point we can measure your displacement simply by measuring the length of that leash, where it would be right here. That would be your displacement there. And then if you keep going, maybe we'd pause the video down here, and your displacement would be the length of that leash when you get there. It's the straight line distance from the beginning to the end of a trip, wherever you are. This length represents your change in position at this point in time. And now you can imagine, as you come back around the track and get all the way back to the beginning, what has happened to the leash? Well, it has come all the way back in. It's all the way back into its holster or whatever you call it, and it's zero. Your displacement is zero. So the question, is distance and displacement always going to be the same number? The answer is no. It will be the same number if, as in these examples before, if we did not change direction. The big key here is a direction change. If there is any direction change, just like there was in the car that we used, just like there is on the track, if there's any direction change, the distance and displacement is not going to be the same number. Really important to know that. So there's several examples that we need to know. First of all, we have this example, the hiker that travels 8 miles east and then 2 miles north. What distance has he traveled? Distance is really easy because all we have to do is add them up. The total distance he has traveled is 8 miles plus 2 miles. His total distance is 10 miles. That's pretty simple. That's what you do with every type of problem. Like, this is the first of 3 types of direction change problems that I'm going to show you. And with all of them, to get the distance, you just add up all of the different parts of the journey. The displacement is quite different, though. To get the displacement with any problem, it's really, really important that we draw a picture. So this person travels 8 miles to the east, and that picture would look like this. And then he goes 2 miles north. It's really important that we don't do this. And the reason why is because if this is 8, that cannot be 2. We need to draw these pictures to scale. It's also really important that we draw the picture in such a way that we can actually do it. This doesn't work, because this picture says that he split and went in 2 different directions at the same time. That can't happen either. We need to make this actually match what the problem said. He went 8 miles to the east, and then from this point, he goes 2 miles north. Right? So we want to know the displacement. The displacement, once again, the straight line distance from the beginning to the end of the trip. And the straight line between those 2 points, I hope you can see, forms the hypotenuse of a triangle. ABC. The displacement is the hypotenuse. So yes, we are going to do some Pythagorean theorem. A squared plus B squared equals C squared. Algebraically, to solve for C, to get C, all we need to do is take the square root of whatever A squared plus B squared is. So as I've denoted over here, A is 8, B is 2, square root of 8 is 64, square root of 2 is 4, and 64 plus 4 is 68. So to get C, I need the square root of 68. Put that in your calculator, and it will tell you that it is 8.25. But this is not math class anymore, so we can't just give numbers. This is physics. It's real life stuff. 8.25 what? We need a unit. Well, we used miles in this problem, so let's go ahead and keep those units for now. 8.25 miles. But if I leave it like this, this is just the distance. It doesn't tell me much of anything. The displacement tells me, it should tell me where I am. So I need the distance and the direction. So the direction is the straight line distance from the beginning to the end. That gives us the direction. At this point, we are displaced 8.25 miles to the northeast of where we were, of where that person was. Now, we could be more specific and find this angle. I'm not going to do that right now. For right now, we're just going to say 8.25 miles to the northeast, and that's our displacement.